Today's lesson is on exponential growth and decay. Up here we can see an exponential growth function. Some important things to note is that this is what the function looks like. It says b has to be greater than 1, and the x-axis is the asymptote. If you don't know what an asymptote is, it's basically a line that the graph is approaching, but it never touches. So as you can see here, it's approaching the x-axis, but it never actually really touches it. Another thing to note is that the function goes through 0, 1, and 1b. It says the domain is all real numbers and the range is y is greater than 0. So an exponential growth function just looks like it's growing up. Now let's look at the exponential decay function. Once again, I want you to highlight the function. It says b is between 0 and 1. And I need you to see that the x-axis is also the asymptote. Here, the domain is all real numbers, and the range is y is greater than 0. I also want you to note that it goes through the point 0, 1, and 1b. The two functions are really similar. They have the same asymptote. They have the same domain, they have the same range. The only difference is that for the growth function, we're going up. For the decay function, we're going down. Next, we have our compound interest formula. It says P represents the principal, R represents the rate, N represents the number of times it's compounded each year, A represents the amount in the account after T amount of years, so T represents years. And here is our formula. We're going to use it later on. Next we have our exponential growth and decay model. They're basically the same functions as the ones we saw up there. Just here, B represents 1 plus R, and on this one, B represents 1 minus R. But they're the same functions that we saw above, just written differently. Okay, let's move on to the examples. It says in exercises 1 through 4, we need to say whether we have an exponential growth or decay. We need to figure out the domain, the range, the y-intercept, and the asymptote. Okay, so remember in the first page, your function looks like this. Here, b is 1 over 12, so we need to figure out whether that's decay or growth. If we look at the first page, it says b is greater than 1, we have an exponential growth. And if b is between 0 and 1, then we're going to have an exponential decay. 1 over 12 is between 0 and 1, so that means that our function is an exponential decay. Next thing I want to do is graph the function. If we look at our first page, we know that one of the points has to go through 0, 1, and the other point has to go through 1, comma, b. In our function, b is 1 over 12. So let's go ahead and plot those points. It should look something like this, and remember that a decay is going down, so let's go ahead and draw that. It should look something like this. It doesn't have to be perfect. The domain for this function is always going to be all real numbers. The range is always going to be y is greater than 0. The y-intercept is where the graph intercepts the y-axis, which is at y equals 1. So y-intercept is y equals 1, and the asymptote, remember, is just the x-axis. Go ahead and do example 2. For example 2, b is 1.5, so here b is greater than 1. Right, so that means we have an exponential growth. Next we want to graph it, so go ahead and plot the points. Remember the points are 0, 1, and 1, comma, b. Here b is 1.5. So it should look something like this, and remember growth means going up, so go ahead and draw that. It should look something like this, it doesn't have to be perfect. And remember domain is always going to be all real numbers. Range is going to be y greater than 0. Y-intercept here is going to be the same as the other one, y equals 1, and the asymptote is going to be x-axis. So as you can see, for all exponential growth and decay functions, domain is always all real numbers. The range is y is greater than 0. The y-intercept is y equals 1. The asymptote is going to be the x-axis. So go ahead and you try to do number 3 and 4. Now let's move on to number 5. Number 5 says the number of bacteria, y in thousands, in a culture can be approximated by the model, and it gives us this function y equals 100 times 1.99 t, where t is the number of hours the culture is incubated. First, we need to tell whether the model represents exponential growth or exponential decay. So we need to figure out what b is. B is going to be this number right there in parentheses. So remember we said if b is greater than 1, then it's going to be growth. So this is exponential growth. Next, we need to identify the hourly percent increase or decrease in the number of bacteria. For that, we're going to use the exponential growth model. Remember I told you that b is the same thing as 1 plus r. So go ahead and write down that formula. Remember that b is 1.99 because that was given to us. We need to figure out what r is. R is going to be the answer to this question. So 1.99 is equal to 1 plus r. In order to solve for r, remember we minus 1 on both sides. So here r is going to be equal to 0.99. If we want to change that into a percentage, we just multiply by 100. So that will just move these two decimal places. So 0.99 is equal to 99%. Next part asks us to estimate when the number of bacteria will be approximately 1 million. First thing we need to do here is divide by 1,000 because in the question it tells us that it's in thousands. So divide this million by 1,000. We get 1 million divided by 1,000 is equal to 1,000. So we need to figure out what t is when y is 1,000. For this, you're going to need your calculator. You probably don't have a calculator at home, but if you want, you can try it when you get to class. So you're going to plug this function in. Y equals 100 times 1.99 to the t power. Instead of t, you're going to write x. And you need to figure out when y is 1,000, what x is going to be. Once you get to class, you can figure that out, but it should be x equals 3.5. And remember that t represents the number of hours, so it's going to be approximately 3.5 hours. Next part tells us to use the given information to find the amount A in the account earning compound interest after 5 years when the principal is 1,250. So we need to use the compound interest formula. So go ahead and write that down. Now I want you to label what each variable represents. So A is what we're looking for. P is the principal interest, which they told us was 1,250. R is our rate, which is 2.25%. We need to remember to turn that percent into a decimal. In order to turn it into a decimal, we need to move this decimal point 2 units back. So we would have 0.0225. Now n is how many times it's compounded. It says it's compounded quarterly. I gave you a table down here. So if it's compounded quarterly, we're going to use n equals 4. The next part that we need is t. T represents the number of years, and here we have 5 years. Go ahead and plug all those numbers back into your equation. If you put this on the calculator, you would get 1,398.4. This represents money, so go ahead and put the dollar sign and then the 0 after the 4. Now I want you to try number 7 on your own. And that's it.